So we are going to work on how to prepare laser cut files for the Sp24 assignment using Rhino and Grasshopper definition that I shared with you on 233 assignment container 4. You can find that under resources and Bowerbird template, and it opens this file. But before we come to that, just read through this file, this assignment carefully, and look at what the goals are. I'm going to describe you today the technical parts only. So our goal is to design a sculpted hill, something similar to here, and slice it and send the slices for laser cutting. I'll do it today with you. So the example that I am sharing with you is something like this. So there's a ramp that goes up. There's a ramp that goes up. There's a plateau, and there's a cave. Of course, this is a very, very simple model, but this is for the demonstration purposes only, okay? Don't copy this as a good model. This is for demonstration purposes. How do we create something like this? So I'm going to get this and move it to maybe a layer. I'll select this one and put it here for now and turn this off so we don't see it. Right. So what do we need? We need first to understand what is the scale of our drawing environment. So when I look at this, this is composed of grid. So when you create a new file, use the template, use from the template, there is, you can get a simple object, small objects in inches, because we are working on inches, small objects in inches, that if you start with this template, everything will be just fine. That's how I started. But in case you didn't, or you want to check, come here under Files, Settings, check out your model. Unit is inches, okay? And the layout is also in inches. So we have this two set to inches. Make sure that that is the case. Otherwise, your model will not be okay. So remember, our box is going to be 8 inch by 8 inch from this assignment, right? So what is it? Create a solid max bounding box. The sculpted hill is going to fit into 8 inch, but 8 inch bounding box. So that's what we will do. So something like this, right? If I create a box, regular box, from here, I can enter here 8 by 8, and the height is going to be 8 inch. So this is how it will look like. Get this object. This is the hill. So what we can do with this box, I mean, you can go from pieces to whole or from a whole to pieces, follow the architectural style that we covered in the lecture, mass and volume architecture. Let's carve this. Let's start carving this. Maybe I will carve a ramp here, right? How do I do that? So I take, go to C-planes, take my C-plane to this surface. That means that I'm going to sketch here something that will identify my ramp. Here, the coordinate system has changed. I'm going to create a polyline. Let's create a polyline. The polyline will move from here to there. And then maybe, yeah, sometimes it is easy to draw it on the other part. So here, and here, and here, and here. So what I have here is a polyline. What I can do with this polyline, I can, well, extrude it, right? Extrude this to solid. Extrude. Let's try this. Try this other extrude. Yeah, let's extrude. Let's extrude this one. Extrude stressed. So where do I want to extrude this? Maybe this direction. Let's make our unit to be extruded. What will be this? If you can see that this is Z direction is going on the bottom, it's 5. This is minus direction. So if I come here and I say minus, let's make it 3. So it's not that what I want. Let's get this extrude one more time. Extrude this. Get this. Interesting. That's the Y direction, sorry. So Y direction is positive. That's why it didn't work before. Anyhow, so we will get this one. Let's position it here. Let's cap our object because this object is not solid yet. So I have 2 solids, right? And this poly surface and the other one. Get the curve. I don't need the curve anymore. This is my solid object. This is good, right? So I'm going to get Boolean operation, the difference from here. Take this out. So I got this part done. What I'm going to do next is I'm going to create a plateau here. Maybe on the top view. If I come, I'm going to say I will create a box. Where is it going to start coming? Maybe somewhere. Let's change our coordinate system. If you see here, the C-plane is changing. I'm going to create a box somewhere here. And possibly that is going to be, this is ramp, right? This is ramp. Ramp is not that good somehow. Doesn't work out. It's very steep. Well, okay. For the sake of this exercise, let's assume that it is like this. So I'm going to set maybe another coordinate system and use this coordinate system to create another box. Somewhere here. Let's get this one. That's good. So I'm going to cut this out all the way. This is good. Let's get this one here. Here to maybe here. I want this a little bit further. Go to solid tools, push and pull surfaces. Yeah, this is good. This is better. So let's apply the same difference. I have my plateau created. Let's create another box where I will maybe get this portion out from here. So there is something here that I would like to get out. I will create a cave here, right? So let's say I'm going to create another box, maybe somewhere like this. Right? So maybe height is going to be a little bit high, and then move this box. So notice that this is not something that you should do. This is an example of interaction, how I create boxes and taking the boxes out and bringing the objects into place. So if I want the X and Y to be here, if I want to move an object, I'll teach you. So move this object, point this location. I want X and Y to be here. All right, so for that, I'm going to type point XY is going to be here, and I want Z to be somewhere here. So I got this positioned. Well done. And this is too thin. Maybe I will push this surface a little bit using the same technique I used here. Right, so this one. Push this a little bit. Surface. Surface. This way so that I have enough space in the plateau. So I have this thickness done. Take this out. All right, so something like this, right? There is this plateau, ramp, plateau, and cave. So if you are a little bit adventurous, you can create other holes somewhere else, change the geometry. But let's say I'm happy with this geometry. So you see that there are some faces here that they are not, they are divided. So let's take them out and tell them that they are going to be joined. So we call merge or coplanar surfaces. Select object, and now we have a clean horizontal surface here. The lines disappeared. So it's called merge all coplanar surfaces. So we have this geometry. This is good. So let's create something interesting. Let's deform this. For this, I'm going to create a function called quadrilateral quadrimesh. That means create quadrangular meshes of this object, smooth the edges. When I do this, you see that there are different parameters coming. Quad count, I'm going to say, get me 200. Adapted size is 50%. Okay, convert it to sub-D. If you preview it, it will look like something like this. Right, so the ramp is a little steep. If you increase this to 300, you are going to see that it is a little bit smoother as it goes forward. So I'm happy with this. So let's say, so delete the, if you want, you can delete the hard edges, control it. You can play with this on your own time. Our goal is to use the laser cutting part, okay, for this. So this is covering the basic functionality. Notice that we have two objects now. This is hide this object. So we just created this. Right. So this is fitting in 8 by 8 inch square cube, sorry, 8 inch, 8 inch, 8 inch cube. Now what I will do next is set this object for my slicing algorithm. So let me push this aside by pushing this, using this, because I need some space where the slices will be generated. Right, now come back to this Bowerbird layout, open it. How you open Grasshopper? Go to Rhino, go to Tools, open Grasshopper. Okay, and then after you open it, you will see this. Open the Bowerbird with layout HIE. That's my initials. Beta 01 with layout. Okay, let's save this one. And you see this attach your geometry here. Right click on it. Select set 1B rep. This one. And this is going to create slices. That's taking time. I will go over how this is generating it. See, and all the cuts and slices are created. Okay, how is this working? So I'm going to clear this out, these values out, and go over this. Let me get rid of this too, because this is part of it. So I'm going to set first the parameters. What are the parameters that I want? This is, if you move to the right, you will see that there is X slice count, Y slice count, cut thickness, and cut depth. So remember, we are asked to create 10 minimum and 10 slices. So come here and say 10. And come here and say 10. So this cut thickness is 0.15. So 0.15 is actually 5/5 of 32nd inch. 5th 32nd inch. What does that mean? So our cardboards, the one that we will use, is 5/32nd inch. So 5/32nd inch in decimal is going to be 5 divided by 32nd. It is 0.15625, and it goes on. So when the laser cuts it, it makes it a little bit bigger. So for that reason, we are using, so the cardboards, when they are attached, when the slices get together, if they are not loose, if you don't want them loose, we want them a little bit tighter. Okay, so that's why 0.15 is going to work for us. So adjust this thickness to 0.15. Why there are more options? Because you may work with plywood, you may work with fiberglass, you may work with plexiglass or other material. But depending on the material thickness, you adjust this. All right. So the next thing that I need to adjust after these parameters is the layout, the cardboard dimensions. So if you look at here, this is our component for laying out the slices on the cardboard. In order to do this, what I need is a cardboard drawing. Where is it going to be? Somewhere here. I'm going to introduce a prototype cardboard. So the cardboard is a rectangular profile, of course, Remember, our cardboard is 32-inch wide, 18-inch high height. So get this one, 0.0. So I would like to get to the right corner is going to be 32 by 18. For this, I'm going to enter here. Enter, add sign. That means from that absolute reference, 32 by 18. Once you do this, you see this is one cardboard size, 32 by 18. So the given cardboard to you, if you come here, is, where is that one? Yes, 32-inch by 18-inch size. That's our cardboard. And the thickness is 5/32 thick. So let's put this aside. Okay, so I am done. You see this here, the icon that I'm going to highlight. This one, this is where you will attach your cardboard. So go here, right click, set curve. This is my curve, right? So set one curve, this is it. So the cardboard is defined 18 by 32. Right? So this is, let's check its dimensions, right? So if you want to check any dimension, you come here, say length. Sorry. Analyze distance from here to there. That is given to me under here, 32 inches. And from here to there, it is given to me 18 inches, Y and X. So that's good enough for me now. So I set my diameter, the boundary by clicking on this. I'm going to talk about the others later because they are more relevant when we are adjusting the layouts. So all is actually, now, remember we attached the geometry before. We are going to attach it again. Right click on the first object, we will select set one BRAP, which is this one, and let the system do its magic. It takes some time to create objects. Well done. Okay, so that's essentially it. That is like X direction slices along the X direction, Y direction slices, and this is our cardboard. So there are 1, 2, 3 cardboards that we will send for laser cutting. Notice that this is not perfectly efficient. One way of playing with this is, again, the parameters that I showed you before. Most likely yours is going to fit into 2. Mine is bulky. But if you come here and say, I would like this placement, if you look at the spacing, it is almost 0, right? So spacing between the slices, let's give them a little bit room so that laser cutting doesn't overlap. Maybe quarter inch, maybe 1/10 of an inch. So you are going to see that slices are going to be put apart a little bit. You see that there's this openings created between them. So this is, you see this here, we don't really like to have connections like this, but let's, for the sake of this exercise, maybe we can control it. Let's look at the top view. All right, so this is it. Parameters that I told you, this is rotation. There are 4 different rotation settings. For instance, if you set it to 3, my algorithm is going to find out how to optimize them on the cardboards. Okay, so let's see. So you see the profiles rotated to find their place. Or maybe if it is 1, y-axis is kept. Sorry, x-axis and y-axis kept and outlined. But whatever it is, we got minimum 3 layouts. Well, we can squeeze them into 1. If into 2, most likely 2.5. But this is good enough. I think this is good enough. So what do we do next? So if you notice that I cannot select them, except this one, I cannot select any of these. So there is a process called baking. If I switch to here, and change my over right corner here, my view mode here. If I change my view mode to be rendered view mode and hide my object, say hide, you see that the slices will look like this when they are brought together. Yeah. So I'm going to switch to the other view. But this is not selectable either. If I come here and I say select these, they are not selectable. The reason is that they are in the algorithm side. They are not brought back, inserted in Rhino. So let me show you how it is done. So we need to bring all these permanently inserted in our Rhino model. I'm going to switch to top view. Right, so here it is. What do I first bring? So bringing a model from Grasshopper to Rhino is called baking. And how do you bake it? Maybe let's bake the solid profiles first. These profiles, right? So I need to have layers set up for this. Maybe I'm going to create a new layer and call them profile X, right? Maybe another one, profile on Y direction. Change their views. Let's take them brown. And the other one, make them sea green. All right, so 2 different things. When I come here in this model, in this Grasshopper model, on the upper right corner, if you select these, you will see that these are the Y direction cuts, parallel to Y axis, and these are X direction cuts. So if you right click on this, bake these, and you say these are going to be on my X profile, and we don't want them to be grouped. When you say bake, they are baked, you see. So now I can select them. All right, so the next one is, of course, this one. Bake these into, it was Y profile, right? All right, then get this one. So this is, if you take any of these profiles, let's take this one, move out, you will see that this is a cardboard in digital model. So I can do anything with it, right? So change the rendering mode, render it. And it's going to look like something like this. Let's go to the shaded mode. Don't waste our computing power. Put it back. I did undo to put it back. So we have this. So if we can do this, how do we bring the others, the profiles? You see this vertical, these profiles? I'm going to switch to top view. These are good. So these are good for references. I can, if I want, I can manually move them to my layout and rotate them. But I already did this. So essentially anything that you see here exists in one of these documents, cardboards. So let's clear this. So therefore, if I only bake these profiles, that will be sufficient for me. So my next step is going to be identifying what they are. All right, so when I click on this is everything. Okay, this is everything. Let's get, so these are profiles. These are cardboard profiles. When I select this, the highlighted yellow ones, let's bake them first. Let's bake them to my default layer. All right, so they are baked. The others are these. I'm going to bake them to my default layer to right click, bake to my default layer. If you want, you can bake them to any layer you want. So I am done with this. Right, I am done with this. So I can let's disable this for now. I'm going to disable this so that it doesn't bother me. And it doesn't use my computing power. When I enable this, it will slice it again and regenerate it. But I did what I want. I completed what I want. So if you notice this, there are certain things we need to create, pay attention to. One is that if you zoom in, this X8 profile is intersecting with the profile corner. So we clear this out. We move them away from the profile cuts. Right, so there is this one. If your grid, when you select an object, if you are moving and it doesn't sit to a proper place, then you can turn on this grid snap and then it will be free to move. This will be much easier to move around. So I'm cleaning this out. Make sure that they stay in the profile. So this, I will avoid anything that intersect. This is okay, this is okay. This is not okay. Let's see, this is partially overlapping. Moving it here. Moving it here. Moving it here. Here. Move this here. profiles. Now, when you look at this, this is not going to help me much, right? This is not going to help me much. Maybe I will not cut it, maybe I will cut it, but I can fix such problems in the spot. So maybe I'm going to create a line. Table. I'm going to create a line from here to intersection here. Oops. Line from here to intersection, and then trim this. Get cutting objects. All right, so that is going to be a big mess when you laser cutting, and it is. Maybe you wanna fix your model to eliminate such things before you generate your model. So that's one problem that you may face with. This is another one. All right, almost, sorry. Done. Done. And the others are okay. Let's accept that they are okay. Maybe I can take one of these and put it here, but still I may need to rotate it. If you want, you can. So I'm going to show you one of these drawings. How do I get this printed? So for that, I'm going to create, I have two different approaches for it. One is that I can either print directly from here, or I can create a layout. Right? So in a layout, in page 1, there is going to be an architectural drawing, doesn't matter. The height is going to be landscape. Remember, that's going to be 32 inch by 18 inch. My paper size. If I apply this, it gives me this, right? It gives me this. That's how my paper size will be. So in where is my coordinates encoding logic? Okay, recording work. Just a second. Okay, so we have this layout created from the layout options, remember? And you can see if you click here, you will see that there's a page created in here. We don't have a view for this, so right click on this. Let's add a detail. A detail is going to display our object. All right, so we can add scale detail or detail. Let's add detail first. So when you look at this, this is a detail that looks at the view. Remember, this is also inch. When you look at the scale on the right-hand side, here, scale, layout scale, and the model scale, we want them to be 1-to-1 because our model is not scaled. We are not enlarging or decreasing the size of the drawings we have. So it's going to be 1 to 1. For this, I'm going to enter 1 to 1. Notice that it is now 1 to 1. And then I'm going to get one of the views aligned here. Well, it is close enough. So when I close this, you will see that it is perfectly on my size. Problem I have is this contour is being seen, this one, this curve, right? This curve. I'm going to hide that curve. I don't want it to be printed. Oops, changing it. One, get this out. So this is, I'm showing you one of the methods, and hide this geometry. No, where did it go? Oh, because our object is sketched as well. So let's disable this one too, so that I don't see it. Enable this. That's okay. Doesn't matter. It's not going to print it now. Right click. These are, oh, that's the axis. Sorry, it's x-axis. That's why it is showing. It's not going to print. So this is one. So we are done with this, right? So that is sheet 1. If you want, you can write down somewhere sheet 1 and you don't forget it. This is done. I'm ready to laser cut this. It's all black, not using any other color. So I can come here. No. Okay, so what we would like to do to this drawing is to print it. So you can do the same thing, double click this and duplicate this, change the light, bring the other cardboard layout into view, and then print them one by one. So, or take this one. I'm going to go here and say print. The print will, in the print window, I will select printer output vector, print it black and white, or print in color. It is black, so it's going to print black. That's black and white. I'm going to print in color. Scale is 1 to 1. That is on paper 1 millimeter, 1 inch, in model 1 inch. And then this is going to be, if you want, you can adjust the line thicknesses and so on. But this is for now, good. Go here and say as Adobe PDF. So before you come here, I want to tell you something. People make very often mistake about how objects are seen. Let's come to the top view. See, when you look at these objects, these are contours, right? These are essentially surfaces, and these surfaces have I think this perspective. Take any surface. Oh, now look at this surface. This surface says isocurves. You don't see this, but these lines, when you look at these lines, they appear surface isocurves. You want them to disappear in your model. So if I switch to this, if they are surfaces, you see these isocurves, you want to turn off these isocurves so that they don't appear on your print. Otherwise, your laser cutter is going to come and cut these isocurves and ruin your model. So make sure that you turn off this. That's good. So let's go back to the layout. We have our layout. You can switch to layout from here or from there. Go to print, back to the printing. Remember we said 1 inch is 1 inch. I want to print this. All pages or ranges, we have only one page anyhow, but you can have multiple pages. Go here, save as PDF, and then say save. And save it to a place where it will make sense, right? This, for instance, what is the required naming convention for our model? If you go to the assignments, look at the sculpted profile cuts. So I will name my file as this, right? Sheet 1. If this is group project, make sure that you enter your group ID. Sorry, that's my SFU ID. If this is my group project as well, maybe I will add group 1122 assignment 4 sheet 1. So I will save it here. Once I save this here, I am actually done. So it will appear something like this in Adobe. That you see if I zoom in. So let's check this distance out. We would like this distance to be 0.15 inches, right? So I'm going to measure it. Maybe zoom a little bit more. So this distance has to be 0.5. Let's get my measuring tool. Measure from here. There. Look at this. This is 3.81 millimeters. So what is it in inches? If you say 0.15 inch in millimeters, it is 3.81. So exactly the same dimension that I wanted. Okay, so look at this. 0.15 inch is 3.81, which is 3.81. Right, I am done with this measuring. Oops, sorry. I can change this to inches and it will show it inches. But let's don't stick to this. I have this file done, created. It's page 1. And I can have page 2, page 3, and page, so 3 pages. Upload it to Canvas. Here into this assignment. Well, I don't see how you are uploading it, but follow these instructions. Upload each file under here, and Maya is going to cut them for you. That's it. To recap, build your model. Build your model. Slice it. Adjust the parameters. Set the profiles. Clean the details that are going to be very small, tiny, or irregular. And when you are ready, generate layouts. In layouts, 32 by 18 inch cardboards. Bring your profiles in and print them. Good luck, everyone. That's it. If you have any questions regarding modeling, so talk to your TAs, instructors. But practice is going to make it better. Understanding these controls take time. So what we have done today, we created this little geometric box, converted into a sub-D, make it a little bit organic. This is our sculpted hill. To profile, to fabricate it, we use Grasshopper Bowerbird layout definition that I created, and we created these slices. Right. Again, bye everyone.